There is a machine drifting through the darkness between stars right now. It was built by human hands in the 1970s. Its computer is weaker than the calculator in your pocket. Its power source is slowly dying, losing roughly 4 watts every year. And nobody can go out there to repair it. It is more than 15 billion miles from Earth. A signal from that spacecraft takes nearly 23 hours to cross the distance between it and the planet that built it. This is not science fiction. This is Voyager 1. And its final chapter has already begun. The version most people know is simple. A spacecraft was launched, flew past some planets, took incredible pictures, and disappeared into deep space. Technically, that's true. But it leaves out almost everything that makes the story extraordinary. It leaves out the desperation, the stubbornness, the last-second decisions, the slow erosion of a machine that was never supposed to survive this long, and the question NASA is now facing. When Voyager 1 finally goes silent, what exactly will humanity have lost? To understand why that matters, we have to go back to September 5, 1977. Voyager 1 launched from Cape Canaveral aboard a Titan Centaur rocket, beginning a journey that its designers expected to last only a few years. The original mission was built around Jupiter and Saturn. 5 years. That was the basic expectation. Nobody designing the spacecraft in the 1970s was planning for a machine that would still be transmitting scientific data nearly half a century later. Voyager 1 reached Jupiter in 1979 and transformed what scientists knew about the giant planet and its moons. It revealed volcanic activity on Io, something no one had ever directly observed before, and returned images that forced scientists to rethink entire parts of the Jovian system. Then came Saturn in November 1980. Voyager captured extraordinary views of the planet, its rings, and its moons. And after Saturn, the primary mission was essentially complete. Think about that. The mission Voyager 1 was actually designed to perform was finished in 1980. Everything that came afterward was an extension. But extension almost doesn't describe what happened next. Instead of shutting down and becoming another forgotten spacecraft, Voyager 1 kept going. And then one scientist had an idea that would change how humanity remembers the mission. Carl Sagan believed Voyager should turn its camera around before the imaging system was shut down permanently. He wanted it to photograph home. Not Jupiter. Not Saturn. Earth. The idea faced serious objections. Pointing the camera toward the sun could damage the imaging system. There were technical concerns, scheduling problems, and questions about whether the maneuver was worth the resources. For years, the proposal remained uncertain. Eventually, NASA approved it. On February 14, 1990, Voyager 1 turned its cameras toward the solar system one final time. It captured a series of images showing 6 planets. And among them was one tiny image that would become one of the most important photographs ever taken. Earth appeared as a tiny point of light suspended in a beam of scattered sunlight. The entire planet occupied only a fraction of a single pixel. Everything humanity had ever built, every person who had ever lived, every war, every discovery, every song, every tragedy, every act of kindness, all of it existed on that tiny world. And then, shortly afterward, Voyager's cameras were shut down forever. That photograph became known as the pale blue dot. But the cameras going dark did not mean Voyager was finished. It was only beginning the strangest part of its journey. Voyager 1 continued outward, carrying instruments designed to study cosmic rays, magnetic fields, plasma, and the environment beyond the planets. Then, in August 2012, something historic happened. Voyager 1 crossed the heliopause. It entered interstellar space. For the first time, a human-made spacecraft was directly measuring the environment between stars. and it was still transmitting. That distinction matters. Telescopes can observe distant interstellar environments from Earth. Models can simulate them. But Voyager was physically there. Its instruments were actually immersed in interstellar space. And there was no replacement waiting behind it. No backup spacecraft. No rescue mission. No mechanic. Just a machine launched in 1977, traveling farther from Earth every second. Now comes the problem that has been slowly building for decades. Power. Voyager 1 uses a radioisotope thermoelectric generator, or RTG. It converts heat produced by radioactive decay into electricity. There is no solar panel keeping the spacecraft alive. There is no way to recharge the system. The plutonium has been decaying since launch, and the available electrical power has been falling by roughly 4 watts per year. On Earth, 4 watts is almost meaningless. On Voyager 1, 4 watts can determine whether an instrument survives. So NASA has been forced into a process that sounds almost brutal. They have to choose what gets sacrificed next. The spacecraft originally carried a suite of scientific instruments. One by one, they have been turned off. The cameras were shut down decades ago. Other instruments followed over the years. The cosmic ray subsystem was shut down in 2025. Then came another painful decision in 2026. The low-energy charged particle instrument, which had operated for decades, was turned off to preserve power for the remaining systems. An instrument that had survived almost the entire history of the mission was deliberately sacrificed because the spacecraft simply did not have enough electricity left to keep everything running. And that is what makes this stage different. Earlier shutdowns were trades. Lose one capability to preserve several others. But eventually, there are no more easy choices. Every remaining instrument becomes more valuable. Every remaining watt becomes more important. And Voyager's engineers are trying to squeeze every possible year out of a machine that is now operating far beyond anything its designers could reasonably have expected. The spacecraft is still moving outward at roughly 38,000 miles per hour. Its distance from Earth continues to increase. And every command sent from Earth takes nearly a full day to arrive. That means Voyager is not being controlled in real time. Engineers have to think ahead. They send commands knowing that the spacecraft may not receive them for many hours. And while those commands are traveling through space, Voyager continues operating on its own. That delay is going to become even more dramatic. As Voyager moves farther away, the communication time keeps increasing. The signal itself is incredibly faint by the time it reaches Earth. The spacecraft's transmitter produces only a small amount of power, yet the tiny radio signal spreads across an enormous volume of space before eventually reaching the deep space network antennas on Earth. Engineers have to extract that whisper from background noise. And somehow, after nearly half a century, they are still doing it. There is another problem. Voyager does not have unlimited engineering margin. Its computers are ancient by modern standards. Its thrusters have degraded. Its heaters consume precious electricity. Its electronics have spent decades exposed to radiation and extreme cold. And every new problem has to be solved remotely. There is no repair crew. There is no replacement part. There is only the hardware already sitting billions of miles away. NASA engineers have therefore become something close to digital archaeologists, studying decades-old systems and finding ways to make them perform tasks they were never originally designed to perform. One of the most ambitious ideas is an emergency power-saving procedure sometimes called the Big Bang. The concept is to reorganize multiple spacecraft systems in a coordinated operation, reclaiming power from components that are no longer essential and redirecting it toward the systems that matter most. The procedure is risky. A mistake could potentially leave the spacecraft in a much worse condition. But Voyager has reached the point where doing nothing also carries a risk. The mission is running out of options. And that is the strange paradox of Voyager 1. It is not simply dying. It is being actively kept alive. Every shutdown is deliberate. Every watt is budgeted. Every command is calculated. Every surviving instrument exists because engineers decided that its scientific value justified the electricity required to keep it running. And somewhere on the outside of this dying spacecraft is another piece of human history.